Again, welcome to DSRT 734 class. These lectures cover frequency distributions and their graphs. Our main objective is to learn how to construct frequency distributions, frequency histograms, frequency polygons, relative frequency histograms. So we start with the frequency distribution. The main purpose of a frequency distribution is to organize our data. So we use frequency distribution table to organize our data. Here we say a frequency distribution is a table that shows the classes or intervals of data with a count of the number of entries in each class. The frequency F of a class is the number of data entries in the class. So we can see from the table, let's assume we have a data set. And in the data set, the observations that have the values between 1 to 5, we have only 5 of them. Between 6 to 10, we have 8. Between 11 to 15, we have 6. So that's the main goal of a frequency distribution, to organize our data in a tabular form. So here we say the lower class limit, and also we have the upper class limit. Then the class width will be 6 minus 1. And the class width of each class interval must be the same. So 6 minus 1 is 5. 16 minus 11 also is 5. 11 minus 6 also is 5. So let's see the steps we normally use to construct a frequency distribution. The first step, we need to decide on the number of classes. So we can see the example here. We have 1, 2, 3, 4, 5, 6. So we have 6 classes. Now, if the data set we have is values from 1 to 30, or let's say 1 to any amount, here we say 1 to 30, then what we can do is that we can say, okay, we need 4 classes, which means we are going to increase the class width. So the more number of classes we have, the lesser the class width will be. So that's the first step. We need to decide on the number of classes we need. Usually it should be between 5 to 20. Otherwise, it may be difficult to detect any patterns. Then secondly, we need to find the class width. So we need to determine the range of the data. The range of the data, again, will be the difference between the minimal value and the maximum value. That will be the range. Then when we get the range of the data, we need to divide the range by the number of classes. Again, we are going to see an example after we finish this section. So again, in order to find the class width, first we need to determine the range of the data, which is the difference between the largest value and the minimum value. Then we divide that by the number of classes that we chose in step 1. Then we need to round up to the nearest convenient number. So what we mean is that if the answer is 2.1, we are going to make it 3. If it's 2.0, we make it 2. If it's 1.9, we make it 2. So we have to run up to the next convenient number. It should be next. So 3.9 or 3.1 will still give us 4. Then step 3, we need to find the class limit. So you can use the minimum data entry as the lower limit of the first class. Then also we find the remaining lower limit. And as we said earlier, the class width always must be the same. So we find the remaining lower limit. We add the class width to the lower limit of the preceding class. Then we find the upper limit of the first class. And here they say we should remember that the class cannot overlap. What we mean is that if the first class is from 1 to 5, the second class cannot be from 5 to 10 because we have 5 in 2 classes. So all the values must fall within only 1 class. Then we need to find the remaining upper class limits. Now, step 4, we need to make a tally mark for each data entry in the row of the appropriate class. Then we count the tally marks to find the total frequency for each class. So let's see an example. So the example we have here, they say we should find the following the following sample data set lists the number of minutes 50 internet subscribers spent on the internet during their most recent section. Our goal here is to construct a frequency distribution that has 7 classes. So again, we have a sample of data, and this data, we have 50 internet subscribers. And each data is how many minutes they spent on the internet. Now, this data need to be organized. So for example, if I want to look for, let's say, how many subscribers spend 30 minutes, I don't want to go through all the data looking for it. Example, let's say we have over 1,000 internet subscribers. That would be too many to know. So the best will be if we can use the frequency distribution to organize our data. Also, there are many tools we can use. For example, we can use the dot plots. We can use stem and leaf data plot also again to organize our data. But again, first we are starting with the frequency distribution. So we saw the steps. The first step, as we said, we need to know the number of classes we need. In this case, we selected 7, which is given in the question. Or we can zoom in any number. Normally, we said the number of classes should be somewhere between 5 to 20. So if we decided that we are going to use, or we are going to have 7 classes, the next thing we need to do is to find the class width. In order to find the class width, we are going to find the range of the value, which is the maximum value minus the minimum value divided by the number of classes. This gives us 11.29. So the maximum value in the data set is 86. The minimum value is 7. So 86 minus 7 divided by 7, which is the number of classes we selected for the first step, we have 11.29. So we are going to run it up to 12. Now the next step, we have to get our classes. We choose the class width. In order to get the class width, we have to know the lower limit and also the upper limit. So first we start with the lower limit. Normally the lower limit can be the minimum value in our data set. So here we use 7, which is the minimum value as first lower limit. Then we had the class width of 12, because again, we find the class width already to be 12. So we had 12, and that gives us 7, 19, then we add another 12, we get 31, another 12, 43, 55, 67, 79. So again, the class width is exactly 12. And these are 7 classes as we chose in the first step. Now, then next we need to find the upper limit. So if we know that the next value 7 is 19, then we start with the first upper limit should be 18. Now, when we have 18, we know the next is 31. So we'll end up here at 30, and we continue on 42, 54, 66, 78, and the last value is 90. And the same thing, if we find the difference of the upper limit section, each 2 difference of the values, preceding values, will give us 12. The class width will be 12. So now we have our class interval. We haven't finished yet. Now we are going to look at our data to make a tally mark for each data entry in the row of the appropriate class. So when we look at our data set, we found out that we had 6 internet subscribers that spent between 17 to 18 minutes. Then we have 10 internet subscribers that spent between 19 to 30 minutes. We have 13 internet subscribers that spent between 31 to 42 minutes, all the way to the end. And again, the total frequency should give us the total internet subscribers. In this case, it's 50. So the next step is, how do we determine the midpoint? Here, to determine the midpoint of a class, we're going to add the lower class limit plus the upper class limit divided by 2. So it's kind of finding the average of lower and upper class limit. So for example, we have 7 is the lower, 18 is the upper. So to find the midpoint of the first class interval, it will be 7 plus 18 divided by 2. And that gives us 12.5, 24.5, 36.5, etc. Now, the same thing, if we find a difference of 12.5 and 24.5, it will give us 12, which is the class width. And the same thing, 24.5 and 36.5, the difference also will give us 12. Now, next, we can also find the relative frequency of a class. Relative frequency is kind of like finding the proportion or percentage of each class interval. So it will be the frequency of that class divided by the total class. So here we say the relative frequency is equal to class frequency divided by the sample size. So example for the relative frequency for the first class, our frequency of the first class between 7 to 18 is 6. So it will be 6 divided by 50, which will give us 0.12. The next relative frequency will be 10 divided by 50, which will give us 0.2. And the third one is 13, the frequency. So it will be 13 divided by 50. That will give us 0.26. Next, we can also find the cumulative frequency of a class. So that will be the sum, and the keyword is cumulative. So the sum of the frequency for that class and all the previous class. So for example, the first class we start with 6. The second class will be 10 plus 6, which will give us 16. Then the third will be 16 plus 13, that will give us 29. So from here, we can know that if we get a frequency distribution table, we can have the class column, we can have a frequency column, we can also have the relative frequency column, and we can have the cumulative frequency column. If we need a midpoint value also, we can have the midpoint value column also. So that is the overall. So we have our class column, then the frequency, which is the total is 50. We find the midpoint, we find the relative frequency, and we get the cumulative frequency. So next, how do we graph a frequency distribution? This will lead us to histogram. So frequency histogram. A frequency histogram also is used to organize the data. But again, this is a graph. So we will say a graph is a visual representation of data. So here, a bar graph that represents the frequency distribution. So remember, we have 7 classes, or if it's 6 classes, then we are going to have 6 bars. If it's 7 classes, we are going to have 7 bars. So the horizontal scale is always a quantitative and measures the data values. So that's the data values, which is the class intervals. And the vertical again will be the frequency. So the vertical scale measures the frequencies of the classes. So normally, again, from frequency distribution, we can create a frequency histogram using only the class interval, which will be our horizontal, and also the frequency, which will be our vertical axis. Then we may have a consecutive bars must touch each other. In a histogram, they must touch each other. Now we also have a column chart or a bar chart, which normally the bars doesn't touch each other. So next we have what we call the class boundaries. A class boundaries is the numbers that separate classes without forming a gaps between them. So example here, the distance from the upper limit of the first class to the lower limit of the second class is 19 minus 18, which is 1. And we can see from here. Now half this distance is 0.5. So again, the class boundaries is the numbers that separate classes without forming gaps between them. So here we have 6.5 minus 18, 6.5 to 18.5. And then we go to the next, since we already have the 0.5. So we subtract 7. We subtract 0.5 from 7. Then we add 0.5 to 18. So the class boundary will be 6.5 minus 18.5. So that's what we said. The first class lower boundary will be 7 minus 0.5, which gives us 6.5. Then the first class upper boundary will be 18 plus 0.5, which will give us 18.5. So the second will be 19 minus 0.5, then 30 plus 0.5, which will be the second class boundaries. So that will be our final class boundaries. So we can see, first of all, we have 0.5. How do we get the 0.5? Is because we can see that the upper of the first class and the lower limit for the second class, the difference of the two, then we divide by 2. So 19 minus 18 is 1. Half of 1 will give us 0.5. Then we use the 0.5. Subtract the lower side, 0.5 from it, add 0.5 to the upper side. So that's the example for frequency histogram. Now we have our table. We construct our frequency distribution table. Now we are going to construct a frequency histogram for the internet usage frequency distribution. So that's the result from the first example. So the only data we are going to use here will be the class values, which will be the horizontal, then the frequency, which will be the vertical. So we can see our values, the time online, which is the class interval, first between 7 to 18 minutes, we have 6, 19 to 30, we have 10. Now we want to be at the middle, so we just write 12.5, 24.5, etc. in the middle of each, which is using the class boundary. As we can see here, the midpoint. So we have the class boundary, the midpoint to be at the middle of each class, 12.5, 24.5, etc. How do we find the midpoint again? We find the average of the lower and upper limit. So 7 plus 18 divided by 2 will give us 12.5. 19 plus 30 divided by 2 will give us 24.5. And we keep going down. So that will be our, again, frequency histogram using the class boundaries. So next, what is a frequency polygon? We say a frequency polygon is a line graph that emphasizes the continuous change in frequency. So here we are going to use the midpoint to draw a line on each one. So from our previous example, the internet usage frequency distribution table, we can come up with a frequency polygon. In this case, we are going to use the midpoint. So each interval, we have our point in the middle of the bar and we construct the line. So here we say that the graph should begin and end on the horizontal axis. So extend the left side to one class width before the first class midpoint, and also extend the right side to one class width after the last class midpoint. The points here are the midpoints. So we have the class and the midpoint on our horizontal section with the frequency of each. So first we remember it's 12.5. We can look at the table here. Between 7 to 18 class interval, the midpoint is 12.5. Again, how do we get it? 7 plus 18 divided by 2. 19 plus 30 divided by 2 will give me 24.5. So we are using the midpoint as, again, the horizontal, and we stay using the frequency as our vertical to get the points and draw the straight lines to connect each point. The next will be the relative frequency histogram. So this also has the same shape and same horizontal scale as the frequency histogram. So instead of using frequency data, we are going to use the relative frequency. So here we can see the the vertical axis is a relative frequency, but the horizontal remain the same data values, the class interval or the midpoint. So they say we should construct a relative frequency histogram for the internet usage frequency distribution. So we have the relative frequency. Again, we said is the proportion of each class. So to get 0.12, we divide 6 by 50 because the total frequency is 50. We divide 10 by 50, that gives us 0.2, 13 by 50, that gives us 0.26, etc. to the end. Now we are going to use the relative frequency value as our vertical axis. So that will be our solution, relative frequency, and we have the relative values. We can see that the shape is almost the same as the frequency histogram. So that will be the conclusion of these lectures. Again, in these lectures, we learn how we can organize our data, again, using frequency distribution tables, and also frequency histogram, frequency polygons, relative frequency histogram. Again, thank you for your time and see you in the next lectures.